Hey everyone and welcome back. So in today's video we'll be learning about the basics of service discovery and we'll also look into how service discovery is implemented at a console level. Now first let's quickly look into how things are implemented in a typical monolithic based application. So let's assume that this is a complete application where there are two primary subsystems. One is the payment system and second is the messaging system. So if two subsystem within a monolithic application wants to communicate with each other, it is very straightforward. So all you can do is you can have a function call between both of them and that is much more faster and easier thing to do. However, monolithic comes with its own disadvantage. So let's assume that this complete application goes down, then all of the subsystem, be it payment system, be it messaging system or any other system that is part of it will also be unavailable. And this is the reason why organizations typically implement the architecture of distributed systems where there are microservices involved. Now, since services are no longer part of the same application, there is a challenge involved in discovering service. So let's say that instead of bundling two subsystems like payment system and messaging system into a complete bundle, what you do is you separate them out. And if you separate them out, you move to a different server altogether. So in case if a server B goes down, it will not take the entire application down, it will just take the subset of an application down. In this case it is messaging system and so on. Now one of the disadvantage in this kind of an architecture is that how will payment system find where does the messaging system is hosted. So currently it is hosted in server B, tomorrow it might be in server D, or maybe day after tomorrow it might be in server Z. So where exactly does the payment system find out where is the messaging system? So that is the first disadvantage. And second disadvantage is that there is also latency involved primarily because networking comes into picture. So in the first stage, since both of the subsystem were part of the same bundle, you can just make a function call and it is very fast. However, here both of the systems are in different servers altogether and this is the reason why networking also gets involved and can also be the latency here. So in order to overcome this, one of the traditional solution which is being used is load balancer. So what you do is in front of a messaging system or any other system, you add a load balancer here, and within the payment system, you add the DNS of this ELB here. So you hardcode the DNS of this specific load balancer inside the payment system, and whenever payment system wants to communicate to a messaging system, all it does, it refers to the ELB DNS and it forwards the query there. Now, there are many advantages of using a load balancer. One of the example here is that each service can be scaled individually. So if you have a ELB here, you can go ahead and scale the messaging system. So you know that tomorrow there is going to be huge amount of load. So you can start 10 messaging system servers here. So you have server A, server B, server C and so on. And all the payment system needs to do, it needs to forward to the ELB of the messaging system. ELB will in turn take care on how it needs to forward the request to the appropriate healthy messaging system service here. So in cloud environments like AWS, you can actually have a auto scaling here. So behind the ELB, you have a auto scaling group of messaging system, and depending upon various scaling policies that you set, the messaging system will scale accordingly. Now, although the load balancer based approach is used in a lot of organization, it can also come with certain challenges. First one is that load balancer needs to be managed for each individual service here. So currently you have a messaging system and you have a load balancer in front of messaging system here. So tomorrow you have a new system that is upcoming. So you need to have the load balancer for that system as well. So if you have 100 systems, then there can be a need of 100 load balancers there. So that is one challenge that can be faced. Second challenge is you have a single point of failure. So if there is some issue with the ELB here, then all the traffic that comes to this ELB will fail. So this is one of the second disadvantage here. Third disadvantage can be a latency issue. Primarily because once the payment system wants to communicate to the messaging system, the traffic first goes to the ELB. So this is the first hop. From the ELB, there'll be a new connection that will be initiated to the messaging system. Again, it depends upon the exact protocol that is being used, but from ELB, another connection to messaging system. Messaging system and the ELB can also have a latency. So you have a latency between a payment system and a ELB, latency network between ELB and messaging system. So that can also lead to increased latency here. So in order to overcome that, we can make use of service discovery, and for service discovery, Console is a great tool. So with Console service discovery feature, there is a registry that is maintained, and that registry contains all the information about the services that is being used within the organization. So let's say that you have a registry. So let's assume that this is a Console registry, and this registry is maintaining the service name. So in this case, there are two service, payments and messaging, and it is also maintaining the IP address of each service here. So there are certain advantages that this type of architecture provides. So let's assume that the payment service wants to communicate with the messaging service. So in such case, what payment service can do, payment service can send a request to this central registry which states that I want to connect to the messaging service. So registry can return back the information that you can connect to the messaging service as 172.138.10. So if you'll see over here, within the registry, one of the IP address of the messaging here is 172.138.10. And once the payment service get the answer that this is the IP address that it can connect to messaging, it can directly initiate a call here. So this is the basic idea. So let's do one thing. Let's directly jump into a quick demo so that this can be better understood. So I'm within the Console UI, and within the service, you will see that there are two services that are available. One is the Console service and second is the messaging service. Now, as we were discussing, each service can lie in a different server altogether. So here you see that Console service is running only in one server. However, the messaging service is running in two servers, something similar to this diagram where messaging service is running in two servers and it has two set of IP addresses. So let's open this up. So currently here you will see that there are two instances. Each instance is running in a different server. So this is the host name of the server. One is console02 and second is demo03. And it is also showing you the IP address of each one of these servers. So let's also look into it in a CLI based approach. So within the CLI, whenever you want to find the list of IP addresses of the servers that is hosting the messaging service, all you have to do is you have to make a DNS request, and that's about it. So currently we are making a DNS request based on the service name messaging service to Console. So now in the return, Console will go ahead and it will give us the latest set of IP addresses that is hosting messaging service. So you have 134.209 and 206.189. And any other service, let's say payment service, if it wants to communicate to messaging service, it can fetch the IP addresses by making a DNS call and then initiate a request to the appropriate messaging service here. Now along with that, depending upon the type of record that is required, so if we request for an SRV record, not only it will tell you the IP address of the servers which is hosting the messaging service, but it will also tell you the port. So this is much more better. Not only you know IP address, you also know the port. So this becomes much more easier in initiating a connection here. Now, one of the question that comes is, and in fact we'll be looking into it in great detail, is let's say that messaging service is hosted in 172.138.10. Now what happens if the server is down? Will registry in the next step, will it still send that IP address if the server is down? Otherwise, if it still sends the IP address, then there is no use, primarily because payment service will not be able to communicate. So let's quickly look into it. So one of the servers where our messaging service is hosted here, let's go ahead and stop that server altogether. So now within the GUI, you'll see that one more entry related to the server is removed, and console is only returning the IP address where the health check related to messaging service are working perfectly well. In fact, let's also make one more call over here. And now you see only one IP address is returned, and this is basically the IP address where messaging service as well as the server is healthy. That's great. So I hope at a high level overview you understood the basics of service discovery, and we also had a demo on how console implements service discovery here. Now again, when you discuss about the challenges which were typically found in a load balancer based approach, one among them is that load balancer needs to be managed for individual service. Now in terms of a service discovery approach, you do not really need to manage load balancer, primarily because if you have a central registry of console, it will maintain the IP addresses of all the servers managing that service. So load balancer is no longer required. The increased latency part can also be reduced, primarily because now you no longer have to initiate a connection to ELB. ELB will initiate a connection to messaging system and so on. So with the service discovery part, the payment system can directly initiate a connection with the messaging system, and this way we can go ahead and also reduce the latency further. That's great. So this is a high level overview about service discovery. Now again, as we go further, we'll be discussing more in detail about some of the interesting features here. However, for today's video, we'll conclude as of now.